Welcome, and this is Kagenda Kenneth for Chemistry at Heart. In this video, we shall be discussing how ions are formed. Simply said, ions are formed when the number of protons / electrons in an atom of an element don't equal. Let's look at the Bose mode of an atom. An atom is made up of a central mass, which is the nucleus, surrounded by energy shells. The energy shells hold the electrons, and the nucleus holds the protons and neutrons. Protons are positively charged, electrons are negatively charged, and neutrons carry no charge. It's the protons and neutrons that contribute to the mass of the nucleus and eventually the overall mass of the atom, because the mass of the electrons is negligible. So what is an ion? An ion can be thought of an appearance of the element after it has gained stability, that is, after it has either gained or lost electrons. Ions are of two different natures, that is, cations which are formed when electrons are lost and anions which are formed when electrons are gained. Well, let's consider electronic configuration in a simplified way. If the last energy level is full to the maximum, the element is said to be stable. Examples of stable elements you can think of are argon, neon, helium, and that's why they are all considered noble gases or unreactive gases, because stable elements find it very hard to react. Then if the last energy level is not full to the maximum, the element is said to be unstable and it will either lose or gain electrons to become stable. Examples of unstable elements is sodium, where the last energy level is carrying only 1 electron, magnesium, where the last energy level is carrying only 2 electrons, sulfur, where the last energy level is carrying only 6 electrons. You can see that in all those examples, the last energy level is not full to the maximum. So there is a special name given to the electrons in the last energy level, and they are called valency electrons. In some texts, it's called the delocalized electrons. Valence electrons or the delocalized electrons are therefore the number of electrons in the outermost energy level. For example, oxygen has 6 valency electrons, sodium has 1 valency electron, aluminium has 3 valency electrons, among others. So, well, let's dive into the formation of ions. If the valence electrons are from 1 to 4, then the element loses electrons to become stable. What do I mean? Let's look at sodium as an example, whose electronic configuration is simply 2 to 8 to 1, and it means that sodium loses 1 electron to become stable, and that means that its new electronic configuration will be 2 to 8. But how do I know how the electronic configuration of sodium ion is written? Well, to understand this, let me give you a very simple fact. Research has been done on the number of protons and electrons in an atom of an element, and it has been concluded that the number of electrons and protons in the atom of an element are always equal. That is a very fundamental fact in understanding how formation of ions takes place. Number of electrons and protons are always equal. Let's look at sodium as an example. Sodium has electronic configuration 2 to 8 to 1, and this means that sodium has 11 protons and 11 electrons, because the number of protons and the number of electrons are always equal. And because of that, when sodium wants to become stable, it will have to lose 1 electron, because it's always electrons which are lost, and when sodium loses 1 electron, it means that the number of electrons in sodium reduced to 10. And when the number of electrons in sodium reduced to 10, it means that now when we compare protons and electrons in sodium, we shall realize that we are having 1 more proton than electrons. And that means that since protons are positively charged, we are having 1 more positive than the negatives. And that is why we write sodium ions as Na+. Let's look at another example of aluminium, whose electronic configuration is 2 to 8 to 3. This means that aluminium has 13 protons and 13 electrons. And when aluminium wants to become stable, it will have to lose 3 electrons. And when aluminium has lost 3 electrons, it means that the number of electrons in aluminium have reduced to 10. And when we compare protons and electrons, we shall realize that we are having 3 more protons than electrons. This actually means that we are having 3 more positives than negatives. And that means that the electronic configuration of aluminium ion is Al3+, plus to mean 3 more positives. So that is how cations are formed by loss of electrons. Let's look at some other example of sulfur. Sulfur has an electronic configuration of 2 to 8 to 6, and this means that sulfur has 16 protons and 16 electrons. When sulfur wants to gain stability, it will have to get 2 electrons. And what happens when sulfur gets 2 electrons? The number of electrons increase to 18. And when the number of electrons in sulfur increase to 18, it means that now when we compare electrons and protons, we shall realize that we are having 2 more electrons. And this actually means that we are having 2 more negatives. And that explains why the ion of sulfur is written as S2-. Let's look at phosphorus. Phosphorus has an electronic configuration of 2 to 8 to 5. This means that phosphorus has 15 protons and 15 electrons, and when phosphorus wants to gain stability, it will have to gain 3 electrons, and after phosphorus has gained 3 electrons, it means that now it has 18 electrons, and when we compare electrons and protons in phosphorus, we shall realize that we are having 3 more negatives, and that explains why the ion of phosphorus is written as P3 minus. What about chlorine, which is 2 to 8 to 7? Chlorine has 17 electrons and 17 protons, and that means that when chlorine wants to gain stability, it will have to gain 1 more electron. When chlorine gains 1 more electron, it means that the number of electrons in chlorine are 18 and the number of protons in chlorine still remains 17. And that means that when we compare electrons and protons in chlorine, we shall realize that we are having 1 more electron, which actually means 1 more negative. And that means that the ion of chlorine is Cl1 minus, or which is simply written as Cl minus, neglecting the 1. So that is how anions are formed, by gaining electrons. You should be very vigilant in all the examples that we have carried out and notice that it's only the electrons which are changing. The number of protons is always static. Well, thanks for tuning in for this wonderful video. This was Kagenda Kenneth for Chemistry at Heart. Don't forget to subscribe and like this video if you find it awesome. God bless you.